Hello, and welcome to my 7th tutorial offering mathematical support to Open University students studying the module TM111, Introduction to Computing and Information Technology. Today we're going to be looking at a concept which was introduced in earlier tutorials, and we're going to be looking at scientific notation. So far in our mathematical tutorials, we've been looking at how we can round up or round down numbers to a certain number of significant figures and decimal places. We've looked at how we can represent large numbers or small numbers by raising 10 to the power of a certain number. So gigabytes and megabytes, we've seen how they can be represented as 10 to a positive number, a large positive number, whereas very, very small numbers can be represented as 10 to a negative number. But as technologists, we have to be comfortable doing calculations with these numbers, both large and small, and representing the answers in a meaningful and sensible way. That's why very often we round our answers to a certain number of decimal places or significant figures. But just to carry on the story a little bit further, we have to deal with large and small numbers as technologists, and I've covered this in tutorials number 4 and 5. But just to carry on the theme a little bit further, let me just take you through this question. Do you know how far it is from the Earth to the Sun? We would say in round terms it's 93 million miles. Remember, in previous tutorials, we don't like all those zeros. So therefore we try to get rid of them by representing those zeros as 10 to a power. It's easy to write and represent the number like this, and it doesn't lead to mistakes if we had to copy out lots and lots of zeros. So we would write this number, it's 93 million. We might write this as moving an imaginary decimal point 1, 2, 3, 4, 5, 6 places to the left, would get rid of that million in terms of 6 zeros and would represent it as 10 to the power of 6 because we've moved that decimal point 6 places to the left. So I could represent the distance from the Earth to the Sun in terms of 93.0 times 10 to the power of 6 miles. But I want to go one stage further. I want to move that decimal point one more place to the left. So I'm left with a single digit on the left-hand side of the decimal point. By moving it one more decimal point place to the left, I need to raise my 10 to another power. So my distance from the Earth to the Sun can be represented as 9.3 times 10 to the power of 7 miles. So this is representing my 93 million in terms of what we call scientific notation. Now, going a bit further, I can actually represent any number in this particular form. I can represent it by a real, that is a decimal number, times 10 to a power of n, where n is a whole number. Now, a is a decimal number. It can be equal or greater than 1, but it's got to be less than 10. So it's 9.999 or something like that. It's the biggest we can get. But we can start at the bottom end as 1.0 times 10 to an integer power where n is a whole number. It's a whole number. So we saw earlier my broadband speed can be represented as 2.0 times 10 to the power of 7 bits per second. So this is how we can represent any of our numbers we can use in our calculations. We can actually represent them as a single decimal number times 10 to the power of an n, where n is a whole number. Let's have a look at some examples. Here's some big numbers and some small numbers. In this case, I'm going to write the numbers in scientific notation to 2 decimal places. So I want to represent the number in scientific notation, but I only want to represent the decimal places to 2 significant figures. To 2 decimal places. So therefore, we're going to have some rounding. We're going to do some rounding. Now, the mechanism for turning a number into a scientific notation is to move a decimal point. So let's think about adding decimal points to the 2 numbers that don't have them. So there's my first and third numbers now equipped with decimal points. So let's look at my first number. I'm going to turn this into a scientific notation, and I do that by looking at the decimal point and then moving it to the left. And every time I do that, I multiply by 10 to that power. So if I move it 1, it's 10 to the power of 1. If I move it 2, it's 10 to the power of 2, etc. So let's move the decimal point. I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. So that will leave me with 2.34105, etc. But I want my answer to 2 decimal places. So my decimal places are basically 2.3 34105. Now I only want it to 2 decimal places. To 2 decimal places, I always look at the third and then ask the question, is that number 5 or more? If it is, I'll round up. If it isn't, I shall just get rid of all the rest of the decimal places. So the 1 isn't 5 or more, so therefore I shall not use it in any rounding, and I shall get rid of the rest of the decimal places. So I'm left with 2.34 times 10 to the power of 11, because 11 is the number of times I've moved that decimal point. When I round numbers, I always represent them afterwards by showing the level of rounding. So in this case, I'm going to put in brackets after my number to 2 decimal places. My next number is 0.1. Well, my decimal point in this case, I'm going to move it to the right so that I make a whole number at the front. I'm going to move it to the right. Now when I move my decimal point to the right, that means I multiply by 10 to the negative power. When I move it to the left, it's 10 to the plus power. If I move it to the right, it becomes 10 to the negative power. So this number will become, if I move it 1 decimal point place, it will become 1.007 times 10 to the minus 1. But I want this to 2 decimal places. So my decimal places are going to be 0.007. So I look at the third decimal place. Is it 5 or more? Yes, it's 7. So I'll do a bit of rounding up. And that will give me the answer of 1.01 times 10 to the minus 1, because I've moved the decimal point to the right. And again, I show the level of rounding to 2 decimal places. Okay, my third number is very similar to my first one. So again, in this case, I'm going to move the decimal point 1, 2, 3, 4, 5, 6, 7 places. That'll give me 4.501. The third decimal point place is only a 1, so I shan't be rounding up. My last calculation is another decimal number, 0.033. This time I'm going to move the decimal point 1, 2, 3 places to the right. That will give me an answer. That will give me an answer of 3.3098. I'm going to round the number up or down. To do that, I want 2 decimal places. So I look at the third decimal place, which is a 9. 9 is certainly greater than 5, so I'll round this number up, and I'll end up with the answer of 3.31 times 10 to the power of minus 3, because I've moved that decimal point 1, 2, 3 places to the right. Again, I show the level of rounding in my final answer. To conclude again, I always put this reminder in. When we round answers up, we do this to present our answers to the reader or to the listener or whatever. So basically we show it in a reasonable way to show an order of magnitude, to show roughly what the answer is. If we have to do further calculations with our numbers, remember we don't use rounded numbers in further calculations. We must always go back to the original number. Well, I hope you've enjoyed the tutorial, and there's further resources on all of my tutorials can be found on that website. Thank you for listening.